How is everyone? Hello. I'm going to try and not move around so much today, only because welcome to the Gaprogman live coding stream. You'll notice I'm not in my usual coding locale. This is because I'm actually at my parents' house. Shh! Don't tell them. Don't tell them. They may not know that I'm here. They know that I'm here. Don't worry about it. So I'm on a slightly different connection to normal, so I don't know what the video quality is going to be like. I think I'm going to be sort of chocky and choppy. But there you go. I am recording and streaming at the same time. I'll probably push the recording up live because the recording will be slightly better quality. So, what is today's stream all about? Firstly, hello. It's been ages. Hello to everyone who usually tunes in whenever I'm streaming and stuff. What I'm going to be talking about today is I'm going to touch a little bit on test-driven development. Not a lot, just a little bit. Just bear with me a second. I really should have brought the chat up as a separate window earlier, but I didn't because I am a wally. Let's minimize that this time. There we go. So now I have the chat running. So if anybody says anything, I can say hello. So I'm going to say hello. There we go. And nobody's there. That's not a problem. Get rid of that message. Oh, bother. There we go. Right. Okay. So we're ready to go. So what I have right now is I'm going to do test-driven development Fizzbuzz. For those of you who don't know Fizzbuzz is a fantastically simple interview style question. So if you go for an interview for like a junior level developer, you may be asked, hello, no content. I've just seen the message come up. No, you're not a nobody. I wasn't expecting there to be anyone, but there you go. Hello. Hopefully the video is coming through okay. I tend to move around a lot when I'm streaming and talking, so I'm expecting the video to get a bit choppy. So it's going to be a bit stuttery. So there you go. Right. Okay. So yes, Fizzbuzz. It's a standard question that you'll get if you interview for a junior position. So the idea with Fizzbuzz is you write an application that, given a list of numbers in sequential order, you send a number to a method, and it either prints fizz if the number is divisible by 3, buzz if the number is divisible by 5, or fizzbuzz if the number is divisible by both, or if it doesn't match any of those criteria, then just print the number. So if you send a 1, you want to get a 1. If you send a 3, you want to get fizz. If you send 5, you want to get buzz. If you send 15, you get fizzbuzz. Pretty simple, huh? So I'm trying this live. Oh yeah, I'm wearing my Hack24 t-shirt. So for those of you who went to Hack24, I have a video in my YouTube channel somewhere. I should have a link for it over there even. I'm doing this backwards. I should have a link for it there, but I don't. So there you go. If you're on YouTube, you'll be able to see it. Let me just switch there. If you're not on YouTube, then after this stream, go over to my YouTube channel. I'll probably put a link in the chat somewhere. Check that out. There's so it was the Cynical Developer, Paul from codeshare.co.uk, myself, and another gentleman. We entered Hack24, which is a 24-hour programming competition, and we won a whole bunch of prizes. It's one of the reasons why I wear this shirt. Anyway, right, so this is going to be me attempting this live. I haven't done this in a long time. That is Fizzbuzz with test-driven development. The reason I'm doing this is I'm starting to do more code katas more often. So I'll sit down in front of a computer. This is not during work time, obviously, just in my own time. I'll sit down in front of a computer and I will come up with a problem, or I'll look around for code katas and I will just practice certain things. So if I want to learn functional programming, I'll pick a code kata, I'll go grab a language to try it out in, and I'll try that. If I want to learn test-driven development, I'll maybe pick a code kata that is designed to be relatively simple, and do that like I'm going to do here. This is it's a useful thing to do. So if you're not familiar with the phrase kata, it's from it's essentially, I believe, it's from karate. It's a Japanese word and it means to practice. I believe it's Japanese. I mean, it might not be, and it might not even mean to practice. But anyway, if you study martial arts, you'll go through katas, which are pre-designed sets of movements that you will go through to practice and make sure that you have the specific movements drilled into you so they become muscle memory. And that's essentially what we're doing with these. We take a problem and do some stuff to it and make it happen, make the code, make the tests so that you can do it automatically the next time around you come to do it. That's the plan anyway. Right, so let's get started. What I'm going to do is I'm going to minimize this. Okay, so in here, all I've got this useful commands.md. I really should rename this to readme. There we go. Whoops. Read me. There we go. Right, so I'm using Visual Studio Code. You could, if you want to, you could use whatever you want. One thing going in is that as of right now, as of this past week, we're going to be using xunit to build our unit tests. There is an issue. I'll put these in show notes and stuff. There is an issue with xunit 2.3.0 and .NET Framework, .NET Core, 2.1.301. In that when you try to run the tests, you get a whole bunch of issues, a whole bunch of errors that are a bit weird. There is a workaround for this, and the recommended fix is, at the moment, like I say, at the moment, there's probably going to be a new version pushed out soon. If you're watching this, I've put this here actually, if you're watching this in the future, i.e. after 2.4.0 of xunit has been released, you won't have to do this. But essentially what I've done here is I've gotten the latest version of xunit from MyGet, which is like a private NuGet feed. And I've added that to my tests project. So if I open my tests.cs project, you can see there's a reference. Let me drag this out to here and maybe make that full screen. Get rid of this. So you can see here, let me zoom in a little bit. Actually, let me see what that looks like. Yeah, we need to zoom in a bit. So let's zoom in. There we go. That's better, isn't it? Whoops. Right, yeah. So you can see here that I have a reference to xunit right there. I've got a reference to the 2.4.0 beta 3 build 4034, which is, as of the time of doing this stream, the latest version of xunit. So let me bring up this preview here. So to do that, I ran this command against my tests CS proj, and this just says .NET add a package, look for the package called xunit, grab me this version, and look here to get it. It's pretty simple. So then what I've actually built so far, I've done nothing. I'm going to go through the 3 rules of test-driven development. And I'm going to do those, whoops, keep moving the laptop, going to do those live. So what I've done is I've created 2 projects, a source, which is .NET Standard 2 class library, and tests, which is a .NET Core 2.1 application with xunit. That's all I've done so far. I'm going to go through the 3 rules of test-driven development. Those 3 rules are: 1, you don't write any production code until you have a failing test for that production code. 2, you do something else. And 3, don't write any production code until you've written a failing unit test. Red, green, refactor, and profit. I seriously, there are 3 rules and I've forgotten what the 3 are. I'm a bit of a wally. But, so, you want to, we want to write a failing test, write some code which passes the test, refactor it, creating the next unit test, refactor the same code. Again, you're working with it's broken. So the whole idea, the code that you write, the tests you write will fail until you write the code that passes the test. The idea with this is that you're not going to use test-driven development. Some people feel that test-driven development is used to drive the design. I feel that you already have a design and you're writing the tests to match that design, so that design might be the spec. So the spec for this problem is Fizzbuzz. You give it a 3, give it a 3, you get the word fizz. You give it a 5, you give it the word anything divisible by 3. Sorry, you get fizz. Anything divisible by 5, you get buzz. Anything divisible by 3 or 5, 3 and 5. Sorry, you get Fizzbuzz, and anything else you get the number out. So that's our spec. and we're going to use TDD to implement a design which matches the spec. At least that's the hope. Right, let's minimize this. And let's, so if I close that, yeah, so quite simply, if you want to run the tests, you do .NET xunit, and if you want to do a restore, you do .NET restore. So what we're going to need to do is, if I do this and do toggle terminal, let's get a terminal up and running. So if I do ls here, you can see I've got my readme, that's my readme, got source, got tests, right. I am not going to write any production code in source yet. I'll show you these files. Let me just minimize these. So my unit tests class is empty. There is one test called test1, and my source has a class called class1. That's all I have, right? So let's call this Fizzbuzz. Okay. Oh, Fixbuzz. There we go. Fizzbuzz. Let me know in the chat if you can't see the text, and I'll make the text bigger. I don't mind. So the first test we're going to do is that the class exists. So it exists, right? So we're going to test that Fizzbuzz exists. Now the way we're going to do this is we're going to say, get me an instance of the class, and that's it. If that passes, we know that the class exists. If it throws an exception, we know that the test fails because the class doesn't exist. So if I go var Fizzbuzz, Fizzbuzz equals new Fizzbuzz. Oh, that's name of. I am type goodly today. New. There we go. So if I do that, whoops. Now it's not going to compile because it's not right. So if I cd into tests and I do .NET build, you'll watch it go past. Let me extend this out a little bit. You can see where I've stored my stuff. This is potentially going to fail. It should fail. There we go. It passed. Okay, that's interesting. Ha ha ha! Right, tests. There we go. So I don't know whether you saw what happened there. I called my Fizzbuzz tests class Fizzbuzz. So this is the class which will contain all of my tests. And I've said, create me a new Fizzbuzz there. So we want to call this test. So that will now, you can instantly see in the debugger, in the IDE, you can't do it because it doesn't know what it is. We'll do .NET build, we'll see all sorts of errors happen here. So we do a restore, we try and do a build. The type of namespace Fizzbuzz could not be found. Are you missing a directive or reference? So first test, and it already fails, but that's good. We want it to fail. So if I go over here, rename this, I'm gonna rename this to Fizzbuzz. Now there's some people who go like, I'm sure you'll have seen, if you know much about Fizzbuzz, if you do a quick Google for it, you'll have seen, let me just rename this, you'll have seen that there is a enterprise Fizzbuzz, and that is Fizzbuzz taken to the extreme. There's interfaces and all sorts of stuff, and it's a parody of your sort of over architecture, but that's not what we're going to do. Some people would create a public interface Fizzbuzz, whoops, and then have this implement the Fizzbuzz interface. I'm not going to, but that's something you could totally do if you were interested in doing what's called outside-in test-driven development. I mean, we could do that here, but this is such a simple system that I just want to do normal. This is so there's three ways of doing test-driven development. There's from the back to the front, from the front to the back, and inside out. So the differences are, if you imagine an N-tier architecture app, so like a standard MVC app, you have at the very top what the user interacts with. Let me just bring up my camera so I know where my hands are. So at the very top where the user interacts, you have the UI, and then you might have you'll have UI, controller, services, database in N tier, standard N tier, right? And that's where all your data is coming from. So from the back to the front, you work from the database layer up, building tests up until you get to the user interface. And front to back, you start at the user interface and work your way down until you get to the database, adding tests as you go. And you usually do this for one path. So you might do, if this was fizzbuzz.api, you might check that the Fizzbuzz API controller exists. Then you might check that the Fizzbuzz API controller.generate or process exists, controller action exists. You might then check that the Fizzbuzz service exists. Then the Fizzbuzz.generate response method on that service exists, and that you would then test back up. Yeah, so you've started from the top and gone down, and then there's back to front, which is where you start at the bottom. You start at that Fizzbuzz service, you do all the things for the Fizzbuzz service, then you write the test for the controller, which calls the test for the... Do you see what I mean? Add it up. And then inside out is where you go straight into the middle, and then you work out like that. So that's pretty cool. I'm really not going to do either of those because this class is pretty simple. So we have a class now called Fizzbuzz. It's in the namespace source. This tests.cs project already has a reference to the source project. So I should be able to now go using source, and then that test will now pass. Let's have a look. It's thinking about it. Nope, it doesn't like it. Fizzbuzz could not be found. Why not? .NET build. Oh, we did that. .NET clean. Oh, .NET restore, obviously. Ugh. Let's see what happens. Could not be found. Interesting. So we've restored. We're going to do a build. Let's see what happens. I'm doing this all live. I haven't done this in a while, so let's see what happens. So it restores that, builds that. It still falls over. Why does that not work? New, let's do source.fizzbuzz. There we go. I don't think that's going to work, but we'll try it. Source, namespace, source. Maybe I need to do... there we go. Okay, presumably that's because my namespaces are named weirdly. I'm not going to look into that. I'm just happy that it does it. So our it exists test passes. So if I do .NET xunit and run that, it should say that 0 tests fail, because it will get through that test and nothing will raise a failure. Where are we? So there we go. Tests 1 total, 0 error, 0 failed, took 0.37 seconds. Fantastic. We have our first unit test. Brilliant. And we've done that by following that first rule. We haven't written any production code until we've got a passing test. Now we need to either refactor or write the next test. So what do we have? We've got Fizzbuzz, and that's it. We just have a class. So we need like an evaluate method or something. So let's write a test, public void it evaluates, and then we'll do var fizzbuzz, fizzbuzz equals new source.fizzbuzz. So it has evaluate method. So I'm just checking that it has an evaluate method. So I'm going to go fizzbuzz.evaluate. Evaluate. That's it. That's all I'm testing. Now I know that that method doesn't exist, but let's run it anyway. We'll get a failure because it'll fail to build, presumably. Let's have a look. Oh, I do apologize. I've got a bit of a kind of like hay fever. Oh, interesting. It passed. Well, I know it shouldn't, so let's build it. So I've got a bit of hay fever. What I'm going to try and do is I'm going to try and mute the microphone, which is just over here. Every time that I need to, like that. And that's really interesting. It's building, but it's not. Weird. Oh well, right. So I mean, we can see in the IDE it's not going to pass. Fizzbuzz does not contain an addition for evaluate. So let's just do this. So let's go public void evaluate. There we go. That's it. Hooray! Right, so .NET xunit. Let's run these again. We're in the test directory, yep. So we're going to run these. This is now going to pass because there's nothing stopping it from passing, which is essentially how unit tests work. So we've now got 2 completely running tests. Did we have 2 before? No, we only had 1. Okay, right. So we've got 2 tests. And that's brilliant. Right, so it has an evaluate method. So that's cool. We've done that. We've got a class called Fizzbuzz. We've got an evaluate method. Brilliant. So what we need to do now is we need to make it do something. Again, you do the least amount of code required. You write a failing unit test, and then you write the code to make that work. So what I'm going to do is I am just asking in the chat how the stream is. How is the stream? Like, how's it looking? Is it coming through okay? Can you hear me? So the next thing I want to do is I want to, given a 1, given a 3, I want to get the word fizz back. So let's write a test. Public, void, given 3, get fizz. There we go. Right, so we're gonna refactor the tests. You can see each time around I'm constructing a new instance of Fizzbuzz. So why not? Let's see if we can do this in. Yes, we can. Well, that's helpful. I'm sure there was a way around that, but there you go. Let's go Fizzbuzz tests. We don't need to pass in any parameters, and we want to go var. We want to go private. Fizzbuzz, yeah, that'll do. And then we'll go for private read only, I suppose. Yeah, that'll do. And then we'll go Fizzbuzz equals new Fizzbuzz. There we go. So then I can actually take away that. I don't actually need this test anymore, because we don't need to use it. I don't need that line either. We've already shown that it exists, and we're going to use that instance there. So I've refactored already. I've done the red-green refactor. I've done failing unit test, passing unit test, refactor. Now, so far it's been on my tests, but it will do for now. So let me close that. So what do we need to do? We need to, given a 3, get the word fizz. Right, so we're going to go fizzbuzz.evaluate. We're going to do, var response equals fizzbuzz.evaluate 3. Assert is equal. Nope. Assert. Oh, bother. Equals. There we go. So that takes fizz response. Now I've taken the initiative here and said that it should be capitalized. It may not have to be. We already know this is going to fail, because if I try and .NET build this, it should fail to build. Let's have a look. There we go. So cannot assign an implicitly typed variable. So we have said in Fizzbuzz over here it's a void return type. But in the test, we're expecting something back, and we're passing a number in. So it's complaining that there isn't an overload which takes an argument, and it doesn't. I can't assign void to a variable. I don't know what void is, so I'm gonna so we need to change this to a string. I'm gonna pass this a number. Now remember, we want to write the minimal code required to make this test pass. So we are literally just going to return fizz. Return fizz. And if I rebuild, it's the minimum amount of code required to make the test pass. You'll see it builds. Oh, maybe not. Evaluate int parameter number. There is no argument given that corresponds to the required form of parameter number for int. Huh. Let's try the .NET restore. That's weird. Int number. Oh, yes, of course. Right, so we no longer need this test because we've already proved that the evaluate method exists because we're about to test it. So get rid of that test, red, green, refactor. Then we do another build. This is going to fail because equalsing a string. So I need to figure out how to do that, but that's fine. This is an overload of equals. Assert.equal instead. Okay. There we go. So we'll do another .NET build. Brilliant. .NET xunit. This will take a second. .NET xunit is doing its thing, and Wallop. We now have a fully running test. Now, remember, this is test-driven development, right? The least amount of tests possible required to make the test pass. So you'll notice I've created a method on the Fizzbuzz, and I've given it the number 3, and it's giving me the word fizz. And my method so far has satisfied that. It's just returned the word fizz. So what do we need to do? We need to figure out how to get it to do. So if I do fact public void given, whoops, I've done a tab there, given 5 returns buzz. I'm going to slightly rename this one from get to returns. So usually you would have, in all of your unit tests, you have an arrange, act, and assert. Some people have different names for them. I really like arrange, act, assert. You can have as many asserts as you need in a test to be able to test one thing. Remember, each test tests one specific part of your code. So you can see here that this is my assert. Let me move that across. There we go. So arrange is setting everything up. Technically, so far my constructor is the arrange method. Whoops. So let's put arrange in there. Let's quit out of that. Move this over here, and the act is do something and then check the result. So there's my act, do the thing, assert, check the response from the thing. Right, so let's do this. So we want to go act, we want to call the response, oh dear, response equals fizzbuzz.evaluate, whoops, not equals, evaluate. Well, we're going to pass it a 5, right? Assert, whoops, yeah, assert dot equal buzz, whoops, oh bother, because I'm using my Mac, you see. So those of you who can't tell, I am from the UK. Some people can't tell, actually. It's a bit of a silly thing to say, really. And on the UK Mac keyboard, it's laid out exactly like an American Mac keyboard. So your double quotes is near the shift key, and the above the 2 is the @ symbol. On a UK keyboard, they're the other way around. So I just messed that up. Right, so this test, we're going to pass in 5, we're going to get the word buzz. I'm not even going to look at the production code. I know the test is going to fail. I'm not going to look at the production code. I'm just going to run it. I've got to write a failing unit test first. I already know this is going to fail. Excuse me. So let's see if we can get it to fail. There we go. So I have a pause for the cause for a sip. Right, so it discovered the tests. It failed here, given 5 returns buzz. It wanted a buzz, but it was given fizz. So now we've got to go and make that work. So let's have a look. Right. Okay, so why don't we do, remember, the least amount of code required. Why don't we do number equals 3, return fizz, otherwise return buzz. All we want to do is make this pass. Yeah, we're going to make this a lot smarter in a moment, but all we've got to do is make it pass. So here comes Fizzbuzz, here comes the tests, and they all pass. Because we're passing in 3, we get fizz, we're passing anything else, we got buzz, that's fine. That's made our, when you pass 5 into it, it returns buzz. What about if we do, whoops, oh, what have I done here? Oh yes, public void given 15 returns fizz buzz. Can you already see, as I'm writing this, can you already see what's going to happen? For response fizzbuzz.evaluate 15 assert dot equal, so we want to get out fizz buzz. Again, I'm taking the initiative here and assuming that it would be camel case, but that's not a problem. So, whoops, I'm returning a type of voif, apparently. So that's good. Right, so we have our 3 tests. Let me scroll up. Given 3, return fizz. Given 5, returns buzz. given 15 returns Fizzbuzz. This isn't going to work, is it? Or is it? Let's find out. What do you think is going to happen? I'm just going to have another sip. It's important when doing test-driven development to remain hydrated. So please do that. It's important when doing anything to remain hydrated. But there you go. Right, so we've said the given 15 returns Fizzbuzz has failed because it expected Fizzbuzz and it has got buzz. Right, okay, let's write the minimum number of code, the minimum amount of code to make this work. How about a switch statement? Yeah, let's do a switch statement. Okay, so that'll do it, because we just want to do switch on number, case 3, return fizz. There is a wonderful extension for Visual Studio Code. Oh, by the way, this is Visual Studio Code. I'm using this because it's extremely lightweight and it won't clog up my RAM or anything like that. Case 15. There is a wonderful extension for Visual Studio Code that will do yeah, and then we'll do default in here as well. Default. Let's do a throw. Throw new argument exception. That'll do. So there's a wonderful extension for Visual Studio Code. I don't have it installed. It's on a Scott Hanselman blog post. He uses it a lot. It's wonderful. What it does is it gives you little coloured bars next to your unit tests, and if you enable constant running of your unit tests, so you do .NET watch xunit, so you would do .NET watch xunit, what happens is that tells the .NET Core SDK to constantly to watch all of the source code, and when something changes, it will rerun your tests, and that way you get live tests running. So as you're making changes to your file, all of your tests are being rerun to make sure that everything passes. I'm not going to do that, but that is a wonderful thing. I'll put it into the show notes for the YouTube version of this, on the blog post that goes along with it, and if I can find it after I finish streaming, before I close everything down, I'll put a link in the chat for people who are watching live. How is the live stream for anyone who's watching, by the way? I hope it's going okay. I hope it's coming through fine. I don't have that extension installed, and I don't even know the name of it off the top of my head. I just know that it's one that Hanselman really likes, and it is really cool. I'm going to install it myself as I start doing more of these katas. Anyway, right, so we've got our 3 tests, fizz, buzz, and 15. And we've changed our Fizzbuzz to do a switch on the number. So we're going to throw a default argument exception. I've kind of had to do that. Actually, no, let's do, right, we want minimal required code. Right? Oh, bother. That's something that some of us Brits say a lot. Oh, bother. Right, there we go. Minimum code required. Switch on the number 35, Fizzbuzz, return Fizzbuzz. Right? So if it doesn't match either of those, it'll return Fizzbuzz. Okay, so .NET xunit. Let's run these tests. Excuse me one moment. Sorry about that. I had to do a big cough. So it's probably best you don't hear it. Fantastic. We've got 3 tests and all tests pass. Can you see that? We've got 3 tests in here. Let me collapse these if I can. 1, 2. Oh, Visual Studio's collapsed. It doesn't look very nice, does it? Anyway, right, so that's cool. So that's given 3, return fizz, given 5, return buzz, given 15, returns Fizzbuzz. What about the other case where we pass in a number that is not 3, 5, or 15? Right? Fact public void given number, given neither 3 or 15 or 5 or 15, return number. So that's not a very good name, but it will do for now, right? So what we're going to do is we're going to go var response equals Fizzbuzz. I'm going to pass in 1. Oh no, we want Fizzbuzz.evaluate, and we want to say So we'll do that as our act. I don't need to put these comments in, but I'm doing them anyway. Whoops. Assert dot is equal. Nope. Equal. There we go. And we want to assert that this string is what we get out of here. Right. This isn't going to work, remember, because our Fizzbuzz does the minimum required. So we pass in 3, brilliant, we get those, brilliant. Okay, so why don't we do this? And remember, we've got red, green, refactor, right? So we've got red, we're going to come into red, we're going to make it green, and then we're going to refactor everything. We passed in something that wasn't 3, 5, or 15, and we got Fizzbuzz out because of the way that this works. So why don't we change this? So we pass the number in. So then this would be, take that, case 15. We're very, very slowly getting towards the response here that we want, but number.toString. There we go. It's not very memory efficient, but it will do. Okay? Brilliant. So let's run this again. Remember, least amount of code required to get it working. This is not the actual... It isn't the actual answer to this test. So if you rocked up to a job interview as a junior and you were told to implement Fizzbuzz in C# and you gave them that code, that's not the correct answer. It's good enough to get you started, but it's not the correct answer, because remember, in TDD we're doing the least amount of work possible to make it work, right? To make it pass. So what I'm going to do is I'm going to refactor these, right? So I'm going to say given multiple of 3. Remember, it's got to be the actual spec was a multiple of 3. A number that is divisible by 3 has to return Fizz. So let's see. We'll make a theory. Is it like this? Yep. So we'll go 3. Is that how you do theories? Oh, nope. I'm going to have to learn how to do theories, I think. Theory. So let's go to the theory attribute. Let's have a look. Marks the test method as being a data theory. Let's make this a little bigger so I've got more room. Data theory is a test which I fed various bits of data from a data source. Okay. So how do I give theories? Let's have a quick look on the web. Let's do a new window. XUnit theory. There we go. Getting started with XUnit. It's been a very long time since I did this. So let's have a look. Theory. Right, your first theory. Here we go. Ah, yes. Okay, right. So, theory. This is no longer a fact now. It's a theory. We're going to go inline data. We're going to go 3. We're going to go inline data. We're going to go 6. Bring this back out so it's the same. So this is saying inline data 9. So remember, I'm not doing this stream as let's get to know XUnit. I'm doing this stream as let's get to know test-driven development. So it's okay if you are doing something like this to have to go and look up how your unit testing system works, because I remember in my first year of university, so I studied at the University of Hull, and the lecturer that I had for Programming 101, which was taught in C#, was Rob Miles. You may know Rob Miles as he is known for the big yellow C# book, the big green C# book, the big pink C# book, or sometimes just known as the C# book. One of the students in the class complained to him and said, "You're not showing us all of the really cool features of Visual Studio. You just..." Because what he would do in his lectures was he would bring up Notepad and a command line, a command prompt, and code using... He would code live in front of us and talk us through something like static or the heap or how variables work, things like that. He would do those live in front of us and use the terminal, the command prompt, to build it. So this was back in 2004, 2005. So this was Windows XP, and this was the command line tools for compiling .NET, which was loads of fun. And his response to this student who said, "You're not teaching us how to use Visual Studio," was, the course isn't how to use Visual Studio. The course is C# and .NET. You know, I would be wasting my time if I was going to show you Visual Studio. And the same thing here. It would be a waste of my time and your time for me to go, oh, let's learn xunit to be able to do this. We're learning I'm showing you test-driven development. I'm using xunit, but I'm having to go in and learn some stuff. That's not a problem. Right. So what this does, remember our other tests here have fact on them. So a fact attribute says that this is a unit test. A theory says for all of the inline data attributes, run this test and pass the number in, right? So if I do number, nope. Oh, how do I do this now? I'm going to mess this up. Let's just quickly have a look. We'll go back to where we were. Have a really quick look because I'm not sure. Int value, right? Okay, so I am going to go int value. And that value is going to be replaced by each of these each time round. I'm just going to move that each time round the loop. So if I do value, so this means right now I'm going to pass in 3, then 6, then 9, and I should get fizz out each time. Again, this isn't going to work. I'm refactoring my tests to make them more stable. Because remember, our spec is not when you pass in 3, you get fizz. It's when you pass in a multiple of 3, you get fizz. So this is going to fail. And that's okay. So we'll just wait for this to go. And fail. So it's failed on 9. I'm not sure why it hit 9 first, but oh no, it failed on 6 and 9. So we passed in 6. We wanted to get fizz. We actually got 6. We wanted to get fizz. We actually got 9. And that's because we passed in 6. It went switch, and doesn't match any of those. Return the number. We passed in 9. Switch. Doesn't pass the number. Doesn't return the number. So why don't we go? So we only want. So for those of you who don't know, there is an operator in C-based languages called the Modular Operator. It is the percentage symbol. It's that one there. Let me zoom in a little bit. Can you see it? Oh, I've zoomed in too far. But you can see it there, look. It looks, oh, bother. It looks a bit like a 9 and a 6, but there you go. Zoom back out. Right. So what I'm going to do is I'm going to go if number. So what the modular operator does, 3 equals 0. I'll explain what this does in a moment. This is how you do Fizzbuzz, by the way. So modulo 3 means take this number, divide it by that number, and get me the remainder. If the remainder of modulo 3 is 0, do whatever this is. So let's return fizz. Now remember, we're doing red, green, refactor. So let's do the red first, do it into green, and then we'll refactor. 3, 6, and 9, when divided by 3, should give us a modulo remainder of 0. So we should get fizz out every single time. Oh, look, we didn't. Why? .NET build. I wonder why. .NET restore. Oh, all this way. It's fallen over. Whoops, I've just done build again. Get out of those. Let's do a restore. All this way, and I've messed up. But let's find out. But this is good. This is good. It's good to get it wrong because then you get it right. Don't worry about it. Let's see, how's the stream going? Let's have a look at some stats. Oh, not good, but there you go. Right. Okay. So we do the restore, we do the build. We're still getting those wrong. I wonder why. If number modulo 3, return fizz. Let's consult Google. Google. C# modular operator. So you won't be able to see the Google that I'm doing, but I'm going to do Google anyway. Excuse me, I've just done it again. Right. Integer division. Remember. Okay. That's very strange. So 3 over 3 should give us 0. 6 over 3 should give us a 0 because we're not after the actual division. We're after the... So why don't we get rid of the switch case for now, because we're getting 9 back. All this way, yeah? Let's have a look. So whilst that is doing its thing, it's still building. So let's have a look at the Modular Operator again. Yeah, well, so that's fine. No, that's going to make one of my tests fail. ToString. Let's do that again. Check over here. Read some more about modular. If number modulo. Number modulo 3 double equals 0, and it doesn't. Right, so .NET build all of the things. One of the things that .NET Core, excuse me, .NET Core 2.1 has, that's interesting, is .NET Clean. That could be useful for cleaning out all of the previously built files. So let's do .NET Build. Is this complaining about one of my tests not returning a value? Probably not. Let's find out. This is slightly not good, but evaluating not all code. Oh, we're making all of these changes, and I didn't save. I don't know whether you saw, but that X becomes a solid circle when you haven't saved. Ugh, what a wally. Right, so we've done a rebuild, about 7 rebuilds, all of that, and I hadn't saved it. Let's have a look, see what happens. So we should get the 3 should pass, 5 and 15 should fail, and the number should still pass. Yeah, given 5 return bus, right, so that's because we commented that out. So let's remove this. That was me trying to get this to work. So we'll go like this, uncomment those, I'm going to take that out. So, right, save. Right, so if modulo 3 fizz, they should now all pass. I may have to do a rebuild actually. Yeah, I will do. It'll fail again because it hasn't. So when you do .NET xunit here, that'll fail. When you run .NET xunit, it doesn't actually rebuild your code. So let's .NET clean just to make sure we get a clean slate. Do that. .NET build. Get the latest version of source. Excuse me. Pull that through. And then we shall do .NET xunit. You see, I like that I've gotten this wrong because it shows that I'm not just like, for all you know, I could have had a separate screen with the answer and I could have been copying it in. But there you go. So what's happened here? Given 15 returns Fizzbuzz. It's failing because it's giving me a fizz. Right, okay. So this is still part of that initial test. You'll notice 15 is it's a multiple of 3 because 3 and 5. We've kind of answered one of the hidden questions here, but that's fine. So what we need to do is we need to go for fizz equals modulo 3. There we go. If fizz, and then we need to go for Fizzbuzz equals number modulo 15. So we're kind of answering one of the later things in the same test. Fizzbuzz. Oh no, we need to do this first. Oh no, that's not right. Modulo 5. So that's buzz. Okay. If fizz and buzz. I know that the idea is to write the least amount of code required, but remember we're refactoring here. So fizzbuzz, whoops, otherwise fizz, otherwise buzz. So we'll get rid of that. Okay, so let's do a .NET clean. So whilst that's cleaning, I'll show you what we've done. So we've said store the value of whether that is 0 or not. So that's going to be a true false. In fizz, store that value in buzz. So whether that's a true false, the same idea. Number modulo 3 means divide number by 3 and give me the remainder. If the remainder is 0, then we know that the number is a multiple of 3. Same thing here, number modulo 5 equals 0, number divide by 5. If the remainder is 0, then we know it's a multiple of 5. Okay, so what we've done is because part of the system is red, green, refactor, we got a red. We couldn't have gone to green without refactoring, so we had to refactor anyway. So I've said if fizz and buzz, return fizzbuzz. Otherwise, if fizz, return fizz. Otherwise, do these two cases. So we'll run that, see what we get. Just give it a second. And you can see how long, and now admittedly I'm describing what I'm doing as I'm doing it, but you can see how long these things take to build up. But you also see how my initial version of it, which is switch number 3, 5, 15, is obviously wrong, but we're getting there, right? Okay, so now we need to go back and do, so we've done given multiple of 3 returns fizz. We're going to change this given multiple of 5, change that to a theory. Now you might be asking yourself, why bother writing all of these tests? Doesn't make sense, right? 10. Now this will be an interesting one. Let's see what happens when we do 15. Right? This one. What do you think is going to happen? If I pass in a multiple of 5, 5, 10, 15, what's going to happen? I'll just leave that there for you to have a little look and figure out for yourself before I run it. What do you think is going to happen? Feel free to, if you're watching this on YouTube, feel free to pause and have a good look. If you're doing it live, then obviously, you've had hopefully enough time to look. So we're going to pass in 5. It's going to go, oh brilliant, give me that value. It's going to go 10. It's going to go, oh brilliant, give me that value. It's going to say 15. Oh brilliant, give me that value. Right? Okay. So, .NET xunit. Let's see what happens. I think I'm going to get 2 failures here. Oh, look at that. There is no value. Oh, of course. What a wally. Int value. I got you all excited and didn't even deliver. Right. Let's try this again. So I think there's going to be two failures. There were 3, but I think we're going to be 2 failures here. Not when we pass the 5, but when we pass the 10 and the 15. When we pass the 10, we expected buzz, but we got 10. But why? So let's have a look. 5 modulo, so 10 modulo 5 is 0. So that's true and that's false. So it doesn't match that one. It doesn't match that one. Switch 5. Oh, buzz. Brilliant. Return number string. So what we need to do is we need to refactor. If buzz, whoops, books, that's right. I can type return. Now this, I know this isn't going to make both test cases pass. But that's just because I'm kind of cheating. So because we're doing that case of 5, I'm going to get rid of that. So we no longer need that. Fabtastic. So now we're going to say if we pass in 5, modulo 3, that's going to be false. That's going to be true. So false and true is false. False is no. True, brilliant, return buzz. Second time around, 10, false, true, false, true, false, true, brilliant. Pass that back. Modulo 15, I'm not going to say what's going to happen with 15. I'm just going to run it. Because it's going to pass, right? Right? Or is it going to fail? Wallop. So it's failed because we passed in 15. That's true and that's true, which means we hit that and that, which means we return buzz. So what do? Oh, well, we could change the test so we don't pass in 15, but we don't want to change the test because, well, what happens if someone gives you 15? Do you want to get fizz or do you want to get buzz? You need to test that eventuality. So what we'll do is we will actually short circuit all of that. We'll do that, right? That'll work, right? That'll fix it. .NET clean. A little cheeky .NET clean. That'll fix it, right? Or will it? Let's find out. .NET build. Will it fix it? That's the question. I need a cheesy lab coat, a big pair of glasses, goggles. Send me a tweet if you know where that's from. Twitter handle's just over there. Send me a tweet if you know what that's from. I'm sure you will. Oh look, it still failed. Because the 15 coming in, true, true, true. No, sorry, 15 coming in, true, 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 brilliant, so we'll return fizz. Oh no. So what we want to do is move that back over here. So we need to change the test. We do need to change the test. So we need to change that to 20. Right, you'll notice it's just a multiple of 3, just a multiple of 5. So this time around, the tests will still run. I think I need to do a clean and a rebuild there. Excuse me. Nope, okay, it's still passed, right, okay. So, oh boy, how to explain this, how to explain this, how to explain this. 3 to 15, yeah. Okay, so because the multiples of 3 and the multiples of 5 will always return Fizzbuzz, you can't test for, you can't pass 15 into this one and you can't pass 15 into that one because you're going to get a different result. You can't really go assert equal buzz or fizz buzz, can you? So let's change this into a theory. You'll see why. Inline data. So we'll go, right, so 15. So we'll go 15. We're going to go inline data 30. And we're going to go inline data 60. We're going to go given multiple of 3 and 5. Return Fizzbuzz int value. Whoops, value. Well done, me. Expand that out. We're going to pass in value. Let's save that. We're going to do .NET xunit. So this is going to do 3 lots of tests for this one, 3 lots of tests for this one, and 3 lots of tests for that one. I'm expecting all of these to pass now. Brilliant. Okay, so all of them passed. Remember, red, green, refactor. So we went from a failing test into a passing test. We changed those tests now. Now we should have a look to see if we can refactor. Can we refactor? What do you think? I think we're pretty much there. Turn number 2 string. So I reckon. So I'm going to write a method, not a test. So it wouldn't be easy to test this, right? So I am going to write a method here, public void. No, let's create another. Let's create a console application which talks to that. So to create the console application, we need a public static class, a console. Oh no, this needs to be called main. I believe, yeah, public static void main string array args. Ooh, that's not quite right, is it? Let's see what happens. So let's do that. .NET new console name console. This creates our console app, so that I can extract that out of here. Brilliant. Okay, we're going to add that same CSproj reference, item group CSproj, from there in here. So what I'm doing here is I'm creating a console app. We can do almost like a visual test, like an integration with it. So we're going to go using source, then we're going to go for each n of 4 bar I is equal to 1, I is less than or equal to 100, I plus plus. So I'm going to write essentially an integration test here. I'm going to go, we need to create Fizzbuzz, so var Fizzbuzz equals new source.fizzbuzz. That's interesting, save that, Fizzbuzz. Why does it come up with a lowercase f? So it wouldn't like that. Anyway, Fizzbuzz, there we go. So then if I do console, console.writeLine, so I'm going to do string interpolation, inline string interpolation. I'm going to go I goes to Fizzbuzz goes to, I'm going to go Fizzbuzz.eval u8 I. Okay, so this is going to loop through 1 to 100. It's going to call Fizzbuzz on each of those numbers and it's going to dump them out to screen. So let's see, where are we? Where are we? We're there, so let's go to the, let's go to the console, .NET build. I'm going to collapse this for a second and I'm going to make this almost full screen. This will be easy to see. Oh, the operand over increment or decrement. Have I done that wrong? Oh yes, I've done 1 plus plus. What a wally, as I would say, as I often do. So the issue there was I was doing 1 plus plus at the end, which gave a really arcane, like the operand of an increment or decrement operator must be a variable property or indexer. It makes sense now, but looking at it, what does that mean? Anyway, right, so let's save that. So then we'll go .NET, net run. So I'm expecting this to loop through every single number between 1 and 100 and output the number until we get to a multiple of 3, where it outputs fizz, and then a multiple of 5, it'll output buzz, and then when it gets to a multiple of 3 or 5, it will print fizzbuzz. Let's see. Oh, look at that. So let's have a look. So, whoops, too far. So we passed in 1 into Fizzbuzz gives us 1, 2 into Fizzbuzz gives us 2, 3 into Fizzbuzz gives us 3, 4 gives us 4, 5 gives us buzz, 6 gives us fizz, 7 gives us 7, 8, 9 gives us fizz, 10 gives us buzz, 11 gives us 11, 12 is fizz, and you can see Fizzbuzz for 15, 18 was fizz. That's an interesting one. That shouldn't have happened. Why did that happen? 19 gave us 19. Oh no, of course. No, 18 is a multiple of 3. I'm sorry. It's 25 to 11 at night, and I've been awake for a lot longer than that. 21 is a multiple of 3. 24 is a multiple of 3. 25 is a multiple of 5. 30 is a multiple of... So you can see... And feel free to watch this back on YouTube as I scroll through this list, and you'll see that every single one of these is correct now. And this is, it's not really a unit test, but it's kind of an integration test. You can write integration tests within xunit, but I thought that this would be simpler and easier to just do like this and do a manual check. You could totally do this in xunit if you wanted to. Sorry, my mind went completely blank because I started figuring out a design for it. You could have a response object. So let's just, I'm not going to create it, but you could totally have something like public class response. So this could be the no, capital R. Call it Fizzbuzz response. Excuse me. Public string response text. I'm pretty bad at naming things, so these are not going to have the best names, and I'm going to spell that wrong. So that's response text, and then you're going to have public. Whoops. Ooblik. Public int input value. So what I'm thinking here is you could totally do this inside of xunit. Every time you call fizzbuzz.evaluate, you create a fizzbuzz response object. You pass in the input value and the response text you get back out, and then you could inside of xunit loop through that. You could create a list of fizzbuzz response objects. Every time you call evaluate, put the input value in and whatever response you get back from evaluate, and then go through that list and check that for all of the threes, or for all modular threes that are not also modular fives, you get fizz, and for every modular 5 that's not a modular 3, you get buzz. And I mean, okay, let's do it. Let's write this test. We may as well. So we've seen that it works, but let's write this test. It's not going to be great. It's not going to be fantastic. Let's actually, whilst we're here, we need to refactor this, don't we? Theory, inline data, 1, int value, pass in value. We want value.toString. There we go. So then if I copy paste this a bunch of times and put in a bunch of numbers, oops, that are not multiples of 3 or 5. So let's copy that in a slightly better way. Let's do, 7. Let's do 40. Let's do 40. Oh, I've got a dangling square bracket. There we go. And let's do 84. Yeah. And run those tests again. .net xunit. So this is passing in a random list of numbers that are not 3, 5, or 15. And I'm going to rename that test. Oh, look. 84 gave us fizz. So let's have a look through our list. 84 is indeed a multiple of 3. Let's have a look on Google just to make sure. 84 divided by 3 is indeed 28. I mean, I could have done that myself and given enough time. Oh, hey Mojoma, welcome to the stream. I'm kind of finishing up a little bit, but you know, I'll give you a quick recap. I'm just gonna have to blow my nose to do that. I'm gonna mute the microphone, so you might hear a clunk because it's a mute switch. So just bear with me a second. That's better. I do apologize. Right, okay. So for the, I hope I pronounced your username right as well. I said Mojoma, but it's probably wrong. For the benefit of Mojoma, what we've done is we've gone through test-driven development processes where we built the tests first using red-green refactor. You write a failing test, make the failing test pass, and then you refactor it, and then add a new test. But what we've ended up doing is we've ended up creating essentially Fizzbuzz, but with unit tests. So if I just collapse this for a second, we've created a class called Fizzbuzz test where we pass in a 3, 6, or a 9, or any other multiple of 3 that I can think of, that I want to think of, and we get fizz out. A 5, 10, 20, we get buzz. 15, 30, 60, we get fizzbuzz. 1, 7, 40, 84, we get the number out. Right? And we've done, to implement that, we've created a method here called Fizzbuzz, which is essentially almost the canonical version of Fizzbuzz. I say almost because lots of people do it differently. This is one way of doing it. I'm just going to give that a little wipe. There we go. And it returns as a little string. So if I run these again, we've actually got a failure because I've put 84 in here. And I need to rename this. So given non-multiple of 3 or 5 comma 5 or 15, return number. Okay, that's a little better. So we'll run this again with a failing unit test, and we'll get a better error message coming out. Yes. Okay. Let's have a look. So yeah, so that's what we've been doing. So we've said we want to pass in 84. 84 is indeed a multiple of 3, so we're supposed to get fizz. So let's change that to 83. Rerun it. We're going to do one last test. These are random numbers. I was just describing how you could. So we'll let this run to completion. Oh, 40 returns buzz. Oh, of course, because it's a multiple of, so 48. Yeah, 48. Interesting that it works the inline data up from the bottom. So it did 83 first, did 84 or whatever it was, then failed on 48. So let's find out. Ah, you see, this is a multiple of, you see? Okay, so let's do 42. That is not going to be a multiple of either, or a half. Oh no, it could, because it could be 12. That's going to be a multiple of 3. 369, yeah it is. I'll tell you what, let's just remove that one. That's fine. So what I'm trying to do is I'm trying to automate test all possible values between 1 and 100. And so I've written these bunch of tests, and these are okay, but they are using random intervals. So what I'm attempting to do is I'm going to basically do this in a unit test. So we can do this as an integration test, it's not a problem. I've done this manually, and if we go cd back, cd console, again this is just for anyone who's joining now. So I'm going to .NET run. So I'm going to run this console app, and it's going to print out all of the numbers. It's more of a manual test. It's okay. Oops, excuse me, sorry about that. It's okay, but you have to manually look through these. So why don't we go back to tests? Whoops. Oh, bother. Tests, there we go. So we'll go back to tests, and we'll write a test all values. So to do this, I'm thinking we could use a model like this. So each time you call fizzbuzz.evaluate, it puts the input value in and takes the response text out. And then what we could do is we could then step through all of those and make sure that we have the right values coming out. So if I go, oh God. So this is not a test I've thought of before now. So given all values between 1 and 100, correct underscore, just to correct Fizzbuzz values returned. So this is completely new. I've not thought of this at all today. So let's basically steal this. So we'll throw this here. We'll put an underscore there. So to make my tests easier, I've got a constructor which just returns me a Fizzbuzz object. So why don't we the list of response objects equals a new list. It's going to complain about that because I've not included it, but we'll go include it in a minute. What did I call it? Fizzbuzz responses. Fizzbuzz response. Jump to the top of the page using system.collections.generic. So this would be if you were asked in a interview, how would you ensure that you run a unit test for this? This would maybe be like a bonus. This would not be what you, I suppose this would not be what you would be asked to do, but let's see if we can do this. So for 1 to 100, what we're going to do is we're going to go list of response objects dot add, yeah, that's right, add new, new Fizzbuzz response, space there, and we'll put that on the next line. So we'll go input equals I, and we'll go response text equals Fizzbuzz dot evaluate I. So that will generate a list of it will go through all the numbers between 1 and 100 and add all of those up. Right, okay, so then we need to do, for each response in list of responses. Right, so var failure equals false. So what we want to do, yeah, it's not being used, that's fine. If response.input, we're essentially recreating Fizzbuzz here, so this is no good, I think. If it's a 3, hang on. We need to check that it's a 3 and if it's a 3, oh god, this is me thinking off the top of my head. So you're about to learn how I put apps together, and no, hang on, right. Fizz equals response dot input value modular 3 equals 0. Buzz equals response dot input value modular 5. Again, this is not terribly great, but if fizz and buzz failure equals response text dot equals fizz buzz string comparison dot invariant culture ignore case. So that's literally just compare these two strings, and I don't care whether the cases are right because you might change the test. If those are the same, do that. If fizz, oh, we need to continue out when we continue. We want to every time round. Yeah, every time round. Oh no, okay. Just loop through it. We'll do it better in a moment. Failure equals response text dot equals. I may as well just copy this line. Let's copy that. There'll be a much more elegant way of doing this, I'm sure, but this is just off the top of my head how I would write a integration test, and it's not a brilliant test, but it will do. I get rid of the buzz, and then if I go out here, so we've gone through the for each, we want to assert equal false failure. What's a good plan about? Oh, failure with a lowercase f. Oh dear, this is not a wonderful test. Don't write this in production because it essentially implements the algorithm to test the algorithm. Oh, .net xunit. There'll be a much better way of integration testing this, and I didn't save, so that is going to fail, so let's cancel that. Let's do it again now that I've saved it. Yeah, so this is not a brilliant integration test, but it's the first one I can think of off the top of my head. Let's see if it passes. Assert equal, oh, assert equal, do not use that to check for Boolean conditions. Correct Fizzbuzz. Expected false, actual true. So something failed. I wonder why. So we won't do continue. What we do is if failure throw new exception. Failed on. This is interesting. I think it's I'm pretty sure it's the test that's fallen over. Response. Oh, bother. Just do that input value. There we go. On that. So why don't we do this here? That should have had a continue, but oh well. That one, if we failed on fizz, and here, I think it's my integration test that has failed. But let's find out. I'm going to have a sip of water. I don't like this integration test because it's repeating the, yeah, you see, failed on 3 gives me fizz. Why? I don't think this is working properly, but there you go. Failed on 3 at fizz, so it failed here. So why don't we do response? Oh bother, response text as well. Let's do that and find out what I actually responded with. I think because it's ignoring the case. I think. So we won't do string.equals, I think. Yeah. Huh. We'll just do string.equals. I think, yeah, it's my faulty integration test that's causing this to fail. So it's not the algorithm, it's the faulty assumptions for my really badly written. Yeah, you see it's doing fizz. So why don't I, instead of that, do response text double equals fizz. You're not supposed to test string equality like that, but let's find out. Oh, of course. See, this is why you don't code at stupid o'clock in the evening, right? I noticed the issue when I changed that. So let's do this. I want to point out where I've been an idiot. What does that do? Response.response text equals fizz. If they are equal, set failure to true. Ugh. So let's undo that and undo that again, and then undo it again. There we go. And do if oh bother, not. I like to put brackets around things like this. Yeah, because then you can see what it's doing. So work out everything in between those brackets and then negate it and then store it in failure. So let's go like that, jump to the end, do that. Again, not a brilliant integration test. The manual integration test was so much better. This should now pass. Check out the chat, nothing's going on, that's fine. Again, you wouldn't write an integration test like this because it's pretty terrible. Oh, you see, failed on 15, Fizzbuzz. Fizz and buzz. It wanted to go into fizz. Huh. We passed in 3. Oh, we passed in 15. It went to 3, it went to 5, and then it fell over. Oh well, it's a badly written integration test anyway. You wouldn't integration test it like this because you're having to use the algorithm that you're testing to test that the algorithm worked. Yeah, you're using the implementation of the algorithm to test whether the implementation of the algorithm worked. So let's get rid of this test because it's pretty bad. It's pretty bad. So let's get rid of that. So, I mean, a much better way of doing this would be to manually add inline data for all of the values you could think of, but I'm just not going to do that. So that essentially is, let's get rid of this method as well. And what I'm going to do is I'll upload this to, I'll throw it onto my GitHub, github.com/caprogman. There'll be a code carters or something repo, and I'll put this Fizzbuzz TDD stuff in there, mainly so that you can see it. You can tell me why I did it wrong and make a pull request if you want. Take some comment, take a copy of it, do whatever you want, and then read through it in your own time. Let's close this. This now passes all of the tests, and it's a pretty solid implementation of Fizzbuzz. I mean, there's no comments, but it's a pretty solid implementation. And the great thing about this is that if I ever... So why would you write unit tests? Okay, so let's say you have... let's say this is in some big enterprise system, and somebody comes along and says, that Fizzbuzz is great, but I want to handle, if I pass in, I want it to be Fizzbuzz Bob, Fizzbuzz Jeff. I'm trying to think of a word that doesn't begin with F or B. So Fizzbuzz Jeff. So I want it to be Fizzbuzz Jeff. So Fizzbuzz Jeff. var Jeff equals number modular. Let's see, you've got a special case 27. Yeah, modular 27 equals that, it double equals 0. Yes, that's right. Now, I want that to be able to support the multiples of 7. And I want it to return Jeff, Fizz and Buzz. If Jeff return, what did I say? Jeff, T, Jeff. Right? Oops. Now, as soon as I do that, I've broken my unit tests. If I run those again, toggle the integrated terminal, .NET xunit. Actually, I haven't broken those unit tests. So I didn't test for 27. Let's add it. I'm expecting it to fail on this one. Inline data 27. Oops. Let's run that test again. So it's going to pass 27 in for the multiple of 3. It should return Fizz. But it's not. It's going to return Jeff. There you go. So it fell over because 27 is 27 a multiple of 3. Let's find out. Whoops. I've pushed the wrong button. Oh dear. I'm doing this an extremely long way because I'm super tired. Divided by 3. Yep, it is. Of course it is. It's a multiple of 9. Anyway, so that fails, right? Because for multiples of 27, we want Jeff. And we'd see that straight away. As soon as you run those unit tests, you would see that that would fail. So you'd have to go back and change your unit test or go back and change your code because you've now changed the code and made the unit test fail. So you would know before you commit this to production, assuming that you're running unit tests before you commit to source control, you would know that as soon as you do a build of this, that you've got a failing unit test and you should go back and change it because you've made changes to the code which has invalidated one of the tests, which means maybe you should rethink the design or maybe rethink one of the tests. It's incredibly useful on huge, I mean for Fizzbuzz, it's over the top, I think. You might be asked to write unit tests for Fizzbuzz, I don't know. If you are, then fantastic, you've got a video that shows you how to do it. But I think that the unit tests for Fizzbuzz is too small a sample. But imagine you had a huge web API project and you have one controller method that was really well tested, and then the business requirements change, and that controller method, instead of returning an OK for let's say that controller method takes a value, does something to the database and returns OK, or returns a 500 error if the database or some service between it and the database fails. What if that then changes to you pass in a value and a true false to do a dry run, essentially to do everything in a transaction? So if you're running in a transaction, you might want a different response. You might not want an OK. You might want OK, but with a message on the end saying also this was a test. That would then, by adding the boolean true false, that would break all of your unit tests like that. As soon as you add that boolean, all of your unit tests would break, and you would know, hey, I've just broken a core piece of functionality in this system. I need to go back and rewrite some unit tests or rethink the unit tests as soon as I have the chance. Again, red, green, refactor. Every time you change something, go back to your unit tests that fail, make the code make them pass. So think about how you can alter the code, or maybe the test is old and it needs to be updated. Think about what you need to do to make the test pass without just return 3, without just return 12, without just return true, without just return OK with a message of this was a test. It forces you to really think about the changes that you're making to the system as you're making them, and the design implementations all the way down the line. Especially if it's going with that web API example. If you changed that and there wasn't a unit test, you wouldn't know that you'd broken your web API controller until someone tried to access that web API controller and realized, oh, wait, I was expecting this to not have a this was a test on the end. Why does it say this was a test? Or I can't access this controller anymore because it's saying, it's returning 404. My controller doesn't exist. Why doesn't my controller exist? And then, and the further away from dev, the further away from local dev that your change gets before someone notices a bug, the more expensive it is to fix it. It's a well-known fact. I'm sure it was in the Pragmatic Programmer. It's probably in the Mythical Man month. It's definitely in Code Complete and definitely in the DevOps Handbook that the further away from the developer who wrote the code gets before a bug is discovered, the more expensive it is to fix. So if I write some code and throw it over the wall to QA, and QA takes a look at it and finds a bug, that's my time to write the code has been wasted. QA's time to test the code has been wasted because the code's got to come back to me to fix to then send over the wall again. Now, if I wrote a unit test for that block of code, then I'd be able to find that simple bug. I'd be able to find, I would know that there was a bug to find before I sent it to QA. QA's job is not necessarily to find issues with your code. It's to ensure that your code is the highest possible quality and standard that it can be. It's why we also have code reviews. But then let's say we fire it over the wall to QA. QA doesn't think, oh, I'd better test this method for whatever reason. Maybe they haven't had their coffee. Maybe it's, I don't know. But yeah, so they think, oh, brilliant, just pass that. Brilliant, pass it on. That gets out of QA into end user test. At which point your customer is testing that code. They then go, it doesn't matter, I don't need to test it. I'm sure they've tested it. Then goes out to production. Somebody then is using a SPA, a single page application, or they're using some kind of system that integrates with your system. Maybe your system's a microservice. And then all hell breaks loose because their code fails because you've returned a 404. At which point, your customer's customer has then wasted their time trying to access your code and it doesn't work. So they have to file a bug report with your customer, who then has to file a bug report with you, and then you have to go through the whole estimation process. You've got to then do, if you're doing agile, if you're doing estimation, you've got to fit it into a sprint. You've got to maybe fast track it through all of your, whichever system you're using to keep track of all of your source control. Maybe using Gitflow, maybe you're not using Gitflow. You need to create a branch to be able to do the fix. Then at that point you then have to retest everything that has happened between you committing that original code with the bug in it and your new test and your new code. So that could have been weeks, that could have been days, that could have been hours, but that still you have to then retest all of that code and then give it to QA to retest, and they have to then become more vigilant at retesting that. Then they have to give it to the customer, who then probably will go, that's the first thing I'm going to test. They then might not test anything else. You may have broken something else. Code then goes out to live, customer uses it, something else breaks, it comes back to you. Now you've gone around with the loop 3 times. Whereas it took me an hour to talk through writing these tests, but I'm also talking through them. I'm not just sitting there bashing away at the keyboard. I'm talking through it, I'm pausing, I'm stopping, I'm rebuilding, I'm taking a drink, I'm blowing my nose, I'm talking to you guys, but I'm also building all of this code. And a lot of people think, oh, well, you write twice as much code. Actually, you don't. I haven't written twice as much code. That is, this here evaluate method is the right amount of code that you would expect. Let me get rid of the stupid test case, my stupid example case. This code here is almost the right amount of code that you would expect for Fizzbuzz. And these tests are 2 lines each. It's not a massive amount of code. And each of those 2 lines helped me to refactor and make this simpler. There is more than likely a much better way to implement this, but this is your textbook implementation of Fizzbuzz. What are you going to do? I've written almost no extra code. It has taken me an hour, but I've talked you through it, and I have fully tested Fizzbuzz. Yes, the implementation test didn't work, but I have a manual implementation test that I can run in my console app. So just to show you that again, I can go here and I can go .NET Run, and I can use mental arithmetic or get a calculator, and I can check that these values that are about to come out into the console are correct. And I'm pretty sure they're all correct, because that's the correct implementation of Fizzbuzz. So that's pretty cool. Anyway, so that was me talking about test-driven development using Fizzbuzz as an example. Let me know in the chat if you're still on Twitch, if it's not boring for you. Let me know on YouTube if you're watching it on YouTube. Check the comments below. Let me know on the blog post if you're watching the video embedded in the blog post. Leave a comment somewhere and let me know what you think. If you like this kind of video and you want me to do more test-driven development, or even just more katas where I work through a small problem and talk through it, let me know. I'm thinking, I've got a few ideas down the pipe for some of these live streams, and some of them are going to be just, I'm working on a project, here is where I am, I'm going to show on screen, the spec, what I'm working on, where I am, and maybe I'll even write some code that I throw into the blog posts. So if you go over to .netcoreblog.com, oh goodness, no, it's not that, it's .netcore.coprogman.com, just over here. Let me rotate my finger. There we go, just over there somewhere. If you go to that website there, you'll see a whole bunch of blog posts that I've written over the past year and a half. No, year and a half. So I've started over there in November 2016, and all of my blog posts there are, I think they're pretty detailed, but that's me. Everything that I write on there, all the code I've written myself. It's quite a lot of code, and I've got a couple of new blog posts that I'm working my way through. I've taken a bit of a break, but I'm working my way through a couple of blog posts, and I'm going to write the code that I put into the blog posts. So if you want, you can totally just tune in next time I do a stream, and I might just be working through the code, at which point I'll probably have music playing in my headphones and I'll be talking to you guys. I don't know. We'll find out. I'll figure it all out. Let me know in comments on the YouTube version of this, or in the chat, or send me a tweet. My Twitter handle's in. Let me check. Let me check where it is. So let me know on Twitter. It's over there somewhere. It says Twitter and then an @ So let me know on Twitter if you want me to do more of these. It did find it. Yeah. So Thrundle's just said in the chat that they joined a little late, about 10 minutes ago. The video is lagging. I do apologize about that. I think it's a combination of my MacBook Air I'm using and the internet connection I'm using. So the internet connection I'm using, I'm getting about 3/4 of 1 megabyte per second up. Yep. 21st century. 3/4 of 1 megabyte per second up. Oh well. It's not a line that's specific for streaming. I'm currently at my parents' house. But I'm recording this as I'm doing it, so I'll put the recording up on YouTube, and I probably won't even edit it. So you all are getting to see this before anyone else. So that's pretty cool. So what I was just saying was, if you like this kind of video, let me know. Send me a comment, send me a tweet. Put a comment on the YouTube video or in the for the blog post. Maybe give me a thumbs up. Ooh, right. So Thundle just said it's probably more like the GPU lags because it gets into a pattern and it sounds fine. So that'll be because it's a MacBook Air. And does it have a GPU? Probably. It's probably sharing the same RAM as my system. Let's have a look. I'll have a look myself. You won't be able to see this screen actually. So let's find out. Yeah, so it's got onboard Intel graphics that uses just over 1 gigabyte of RAM. So it's probably that. I don't know. Maybe I could drop the frame rate as well. I think I'm attempting to stream at 25 frames a second. And I think, it's streaming at 23 frames a second. So that's probably, if I wanted to drop that, I probably could, maybe down to 20. I don't know. I could probably reduce the canvas size as well. That would probably help. I don't know. Anyway, yeah. So, brilliant, Thrundle. Thank you for your input there. What I'm going to do is I'm maybe going to invest in a new laptop. Don't know. I'll see how everyone thinks about that. See how girlfriend thinks about that. She may not agree with me spending loads of money on a laptop, but we'll soon find out. Anyway, yeah. So give me a thumbs up if you like the video. If you like this kind of thing, and I'll do more of them. Put a little comment in the comments if you're watching on YouTube or you're watching through an embedded video on the blog post. Send me a tweet. check out the blog. I hope I'm pointing vaguely near where it is. And I will catch you all another time. Yes, sorry, yes. So Thrundle just said, you mentioned YouTube, but there's no link in your description. That's a really, really, really good point, Thrundle. What I'll actually do is I'll take a moment now to get a link to my YouTube channel. Let me just do this. So I've got Chrome open on another screen and I'm just searching now. This bit's a bit boring to watch, but there you go. Let me tap that button. So I'll put a link in the chat now for the folks who are watching now. That should take you through to the YouTube channel that I have for all of my previous videos. And there's a few things in there for what I've been working on recently. I haven't actually posted anything for 2 months, so this one will be going up as soon as it's ready. So yeah, I don't want to say like and subscribe. I don't want to say hit the like button. If you liked it, give it a like. If you didn't like it, let me know why, and maybe I can change it for next time. Like I said, the YouTube video version of this will probably be slightly clearer quality, and it shouldn't be all stuttery. If not, then I don't know what to do. New laptop, I guess. Anyway, I will catch you all another time. Have fun and have a brilliant Friday evening. It's nearly Saturday where I am right now on, oh my goodness, what's the date? 29th of June 2018. It's almost Saturday morning. But that's the dedication I have to you guys and to spreading the knowledge, you know. I'll catch you another time. Bye everyone.